A very important construct of virtually all programming are conditions and the if, else if, and else statements that they provide. An if statement is used to test conditions and then branch code based on the result. You can also use else if, and or else statements which are appended to provide more complex branching. Note that if you want to use else if or the else statements, you need to start with a single if as well. After a statement is found to be true within one of these if, and else chains, its code is run and the other statements are not tested at all. Now the tested code, which is known as a condition, must evaluate to a Boolean value, which means it must be true or false. If you're dealing with a Boolean variable, it can be evaluated all by itself. But generally what you'll have are conditional statements that compare two items. The double equal sign simply asks, does the left side equal the right side? And note that you need to have two equal signs in order to compare them. If you use one equal sign, it will treat it as an assignment, which is not the outcome you're looking for. There's also not equals, and that's simply to replace the first equal sign in a double equals with an exclamation point, which says this does not equal. There's also support for doing greater than, less than, greater than or equal to, and less than or equal to. Now let's take a look at if, and else statements in action. We're going to start off by creating a variable called number of type int. And we're going to call a theoretical method to get a number value back that we're going to put into it. It's not really important where this came from, but once we get that number back, we're probably going to want to branch our code based on its value. So we can use an if statement. First thing we'll do is we'll say if the number is greater than 20. And if the number is greater than 20, we can put some code inside curly braces. Those are those little braces that come before and after the comment. Any code that we put inside there will run only if number itself was greater than 20. Now we might also decide if number is not greater than 20, we want to test another case. For example, if number is less than or equal to 10. Now if number was already greater than 20, this condition of less than or equal to 10 won't even be considered. But since it wasn't, we're going to consider it, and if our value does fall into there, it will execute any code that lives inside these braces. Now we can also check to see if the first two conditions were not true. If the third condition, if number is equal to 20 exactly, and then it will run this code. Finally, we have the option of using an else, and that will run only if none of the previous conditions are true. You'll note that we can have as many else if statements as we want, but we can only have one if and one else. Sometimes it's important to be able to provide more complex conditions, and that's where some of the neat operators like and, or, and not are very valuable. The and condition really just compares two sides, or rather it compares two sides of a clause using a double ampersand, and if both sides are true, then the statement itself is true. So in this example, if A and B are true, the code will execute. However, if either of them are not true, then the entire condition is evaluated to false. Similarly, there's an or condition that uses two pipes. And as long as one side is true, the entire statement will be evaluated to true. So if A and B are both false here, then it will result in false. Otherwise, it will result in true, because either one or both are true. The not condition applies to a single clause, and if the clause itself is true, then it simply negates it to false, and if it's false, then it negates it to true. So if entering this if not A clause, A is false, then the code will execute underneath it. Finally, conditions can be combined and nested as much as required, and we strongly recommend you use parentheses to group them so you can understand the code more easily. This example here is very sophisticated and would require quite a bit of thinking to understand all the different logic that could occur for A, B, C, D, and E values in order for it to evaluate. But this is actually a valid set of parentheses and conditions and would ultimately come out to be a true or false. Now let's take a look at when we might use some more complex conditions in action. In this block of code, we've got two variables that are calling their own methods. There's number and other. Now our first if statement simply says if number is greater than 10 and if number is less than 20. Now because of the nature of the number, it can only be values between 11 and 19 inclusively. Now if it is, the code inside will execute. But you can also nest if statements within other if statements. So we can also decide that if number is not equal to 15, or if number equals the value of other, it will execute a special block of code. And we could continue to nest further, and we can use an else statement in here if we choose, which will simply run if the number is 15 and does not equal other. So if we came into this block of code and number equaled other, or number equaled 15, or rather number did not equal 15, then we would be in a situation where this code would run. Now since this first competition we're focusing on is the Hold 'em competition, let's take a look at how we might use that within a sample get bet. Now this isn't really a reflection on strategy, it's more to illustrate the use of the if, else if, and else statements. Let's say we started off and we said if the table's stage was the opening stage, meaning that we only have our private cards, we don't know what the community cards are yet, and we obviously have no other information about other users besides potentially what their bets were, we could just decide we're going to call. And we would return the table's call amount property. The call amount property simply says this is the minimum number of chips we would have to bet in order to call the current hand. So if stage is equal to the stage.opening, this will execute, and it will actually finish our functionality within this method. However, if that was false, we might decide that if we have a hand that's greater than or equal to the flush, that we're going to return the minimum to raise amount, which means that it's been pre-calculated the minimum number of chips we would have to bet in order to raise the current hand. And we can return that. And then finally, we might return a 0, which simply says it'll check or fold depending on whether or not the call amount is greater than 0. The nice thing is we don't have to worry about the details of how many chips to bet. We can simply return call amount, minimum to raise amount, or 0 for the majority of cases.